I'll start this problem by making mention of the fact that there are many different ways available to solve a system of three equations and three unknowns, including advanced methods with matrices, determinants, matrix inverses, and stuff like that. I'm going to make the assumption that you like to see a technique using the old-fashioned method of eliminating a variable from two separate pairs of these three equations. And you can make the choice as to which variable you want to eliminate. I noticed that if I add equations 1 and 3 together, that I have minus z and plus z. If I just add them together, the letter z will disappear. And then I'll have an equation with just x and y. And the same for equations 2 and 3. I can eliminate the z, not as easily, but then I'll have another equation with just x and y, and I can eliminate either the x or the y from that pair. So let's see what happens. If I add 1 and 3 together, I'll get 2x minus 3y, and z, negative z plus z is 0. Negative 3 minus 13 adds up to negative 16. And boom, the z is eliminated. So I move down to here. How do I eliminate z from 2 and 3? Well, I can see that there's a minus 6 in front of this z. So if I multiply the second equation by 6 and then add them together, I will have the z's disappear. So I'm going to recopy equation number 2. Equals minus 20. But what I'm going to write underneath that is what I get if I multiply equation 3 by 6. So I've got 6x minus 12y plus 6z equals 6 times negative 13 is, oh, this wasn't a minus 20, it was a plus 20. Negative 78. So when I add them together, I get 8x minus 11y equals negative 58. Let me take a quick double check of that work. Yes, so let me copy those two down. 2x minus 3y equals negative 16. 8x minus 11y equals minus 58. And now from this system, I'm going to choose to eliminate the x. So I'm going to multiply the second equation by, or the top equation by negative 4. And that will give me negative 8x plus 12y equals 64. And I'll recopy this second equation, 8x minus 11y equals minus 58. And why did I do that? Multiply by the negative 4 so that when I add these together, the x's will disappear. 8x minus negative 8x plus 8x is 0. This becomes a y. This becomes a 6. So y is 6. How can I find out one of the other letters? Well, I can put 6 in for y, like right here. And I've got 2x minus 18 equals negative 16. 2x equals 2. X equals 1. So far I've got x equals 1, y equals 6. I still need to find out what z is. So I go back to one of these first three equations, put 1 in for x, 6 in for y, see what happens. I've got 1 minus 6 minus z equals minus 3. Negative 5 minus z equals 3. Minus z equals, this is a minus 3, sorry. Minus z equals 2. Z equals negative 2. So there's your solution set. Right there. And you can check those values in all three equations and you'll see that they do indeed work. There you go.